Three. Oops. Let me find my document. We can cut this out. So, 3, 2, 1. Okay, guys, welcome to Totally Code. We're here to talk about coding. What is code? Where does code come from? How is it used? And why bother? This is a great place to be if you are new to code or interested in computer programming. This podcast is not necessarily meant to be too technical, but we do end up going off the deep end from time to time. But don't worry, Charlotte will reel me in, so forgive us. Although we do hope that you learn something, and most importantly, have fun. I am Bob, and I am here with my lovely wife, Charlotte. Hi there.
Hi, Bob, and hello, world.
Oh, you're going to do that one again.
I like that.
Oh, good. That should be your signature.
Why not? Hello, world.
That's good.
Oh, it's my turn.
Exactly.
So, again, hello, world.
Okay.
Today at Totally Code, this is episode 2, and we're going to be talking about what is code and what are programming languages. So, Bob, why don't you start us out with what is code?
Yeah, let's clarify, because we did talk about this last time. I always think of code as programming languages. And I see it, this is just me, I see it being used kind of as a trendy word now for the word programming. But I think last time we talked, you were very interested in what is this mysterious thing called code, which is actually running the machine and what the machine understands, right? So you and I kind of have a difference of and they're both right. So we really have two things, right?
Right, definitely. There was the concept of what was running the machine, and I thought that was code. And then there was all these programming languages that you were talking about, and I got confused.
Oh, okay. So if you get confused, then I'm sure we confused others.
Well, I didn't realize that there was these two components. I thought they were one and the same.
Oh, yeah, go ahead.
So what is code? So tell me, there's the code that we think of as programming languages, and then there's the code that is what the computer understands. Mm-hmm. So one is called a programming language, and what's the other one called?
It's really called machine code.
Okay, so the machine has its own code, its own language, and then we have our own languages that we use.
Right.
And somewhere in the middle they meet.
Right, and that ends up being a lot of probably what we're going to talk about, which is how do they meet, why do they meet, who made them meet, right?
I guess so, sure.
Okay. Well, we have a long list of programming languages. Let's just talk about languages in general.
Okay, let's talk about the languages.
Right. We did our research, our limited research, but let's talk about like spoken languages, right?
Okay.
No problem.
Okay, so we want to talk about spoken languages. Wikipedia has over 6,500 spoken languages in the world, whereas computer languages, programming languages, Wikipedia indicates that there's 700 to 9,000 different computer languages.
Right. So I took a list, grabbed it, threw it into a spreadsheet, counted how many languages there were, and then we could actually see 715 different computer programming languages, although some other sites said, and we didn't really look into what the criteria was, but the other sites said that there were 8,900 and something odd other programming languages. So to me, the answer is we don't really know, but but there's at least 715.
Right.
Which
at least
surprised me.
Right. You want to name some of them for us?
Well, yeah, I think yes. To do some justice, what I'd like to do is just rattle off a laundry list very quickly, just so people, and then we'll go back and touch on these and kind of where they come from and how did they get there. But of the 715, blah blah blah, however many umpteen languages there are, to me there was a hit list, and this is just my hit list.
I'm going to go through, as you were reading off the hit list, I'm going to circle all the ones that I've actually heard of.
All right, cool.
Okay, so go
Cool.
ahead.
All right, so we'll just bang these out real quick. Ada, Algol, APL, Basic, Bash, Blockly, C, C++, CICS, COBOL, DOS Batch, Fortran, Java, JavaScript, JCL, Julia, Lisp, Pascal, Perl, Python, PL1, PLSQL, Rex, Scratch, Shell, Smalltalk, Snap, SQL, TPF, Visual Basic. So that's just a hit list.
And that was like 30. You told me that you had 30 on your list.
Right.
I knew 16.
Oh, that's
So-
pretty good.
I know. I was surprised.
Wow.
I've actually come in contact with, heard, know a little bit about, know a lot about at least 16 on this list, which I'm pretty impressed with myself.
No, that's great. And so we just had the list so that we kind of make some justice, right? But I would start with saying the mother language, and when we say language, this is like human readable languages. There are other computer programming languages that we touched on a little bit last time called assembly. So let's just leave assembly language by itself. That's kind of this low level programming language that's kind of cryptic and hard for humans to understand, but was used for quite some time on different processors. But the mother language is Algol.
Algol. That was one that I had never heard of.
Well, I almost forgot about it. I mean, it's not something we were taught, and but it's kind of like the Latin of computer programming languages.
So other languages are derived from Algol?
Well, most of the early languages. So, I'm kind of going off some notes, but the big languages, Fortran, COBOL, Lisp, they were all, and Algol were the big four, but those three were derived from Algol.
Cool. Now, it says here that Algol came out in 1958.
Yes.
Wow, that's really early.
Well, yeah, there was a lot of. Let's go talk to. I know we want to talk about this lady, Grace Hopper. Let's talk about her for a minute because she was instrumental in this transition, in that time period.
Yes, that's true. Yes. So why don't you talk to us about what the transition is?
Well, at the time, again.
Where is this transition?
Well, where is it?
Like, what is it?
Well,
Tell us where the deficit was and that why we needed.
All right. So I think straightforward. There was a lot of hardware that was developed to do computing, and the hardware was, it was relatively primitive, and we could move information around, and there were core languages that came with the hardware, basically. I mean, essentially, that were called assembly languages. So these were like low-level languages. So you couldn't, when you looked at it as a human, as a regular person, you couldn't read it. I'm not sure if I'm explaining it right, but
Can I summarize?
yeah, please.
Okay, so way back when, the beginning of the computing time frame, we had this computer machine language, which the machine understood. Now, along comes Grace Hopper, who had this vision that the machine could understand our everyday language, learning that we could write in our language and the computer could understand it. So Grace Hopper created a compiler. She worked on one of the first compilers, which converts the English language into the computer language or machine language.
Right. So she worked on the lexicon to make that happen. And then the work she did led to the COBOL.
That's correct.
Right.
And she did all this in 1952.
52?
52.
Oh, okay.
By 1952, she had finished completing the programming of her compiler.
Cool.
Yep.
Yeah, and she goes on to win the Presidential Medal of Freedom.
That's right. She even has a destroyer named after her, the USS Hopper.
Yes.
She was a naval person.
Right.
Officer, actually.
Rear Admiral.
Yeah.
Right.
Really
And
impressive,
that
right?
happens later on. So she's an interesting story.
There's a lot of interesting women in computer programming that I think we could do a whole episode on that.
Well, let's hit a couple real quickly. We can go back to our cheat sheet, but one that comes to mind is, the original programmer, Ada Lovelace, which there's a language named after her.
Right? Ada.
And that was in Ada, right? And that was in 1850. So I didn't say 1950, I said 1850.
What did she do in 1850?
So let's remember, 1850 is 170 years ago. She did all of the conceptual mathematics to write programs on what at the time was called the analytical engine. That was a mechanical engine that was created by Charles Babbage.
So that was hardware.
Oh, yeah. Well, but she did all the kind of what we would call today the software.
Oh. She actually did the computer programming for this machine.
Right. What she really did was she figured out a way to use the analytical engine to solve mathematical equations, specifically like the quadratic equation, like x squared plus 2x plus 1. How do you solve that? Right? And she solved those equations.
Using this machine.
She did.
Wow, that's amazing.
There's a caveat, though. A lot of this was theoretical. The analytical engine, even though it was designed and mostly built, it never actually ran.
It didn't run.
Didn't run. No.
Oh my gosh.
But you can see it today. It's I believe it's in one of the maritime museums in London or Greenwich, England. Right.
Nice.
So the machines are available to see.
That sounds like a road trip.
Right. So, but I know we keep getting distracted. What was I going to say?
we're talking
about women, right?
We were talking about women in programming languages, right?
So, Margaret Hamilton, another prominent woman, she worked for NASA and she ran the 3 guidance systems for the Apollo mission. There, if you look on the cheat sheet, see if we can find it. There's a consortium that builds COBOL. Can you read that, or can you find that? It was on the new cheat sheet. We have lots of cheat sheets here. We have tons of information. We should try to publish this stuff on our social media.
So I do have the COBOL 1960. COBOL stands for the Common Business Oriented Language. The consortium was led by Mary Hawes, Grace Hopper, Jean Sammet,
Saul Gorn. What's wrong? Can you not read my notes?
No, I can. I just
So there's 3 women there. Of the 4 people that really led this initiative for COBOL, which becomes a huge business language, 4 of the people are women.
Okay.
Right? So there are plenty of women that are instrumental and significantly instrumental in the computer programming world.
Okay.
Right. So this would be a good time to pause. And what I wanted to do is we want to talk about our social media very quickly. So we are on most of the social media outlets, specifically Facebook, LinkedIn, Instagram, and Twitter, if I could ever get that to work.
Twitter.
It should be Quitter. I can't even figure it out. So please go to those platforms, search up Totally Code. You'll find us. What we would really love is to hear from you, what you're interested in, and what you'd like us to talk about. So please message us and follow us.
Sounds good.
Right. So let's, we want to dive into a couple of these languages just to kind of get some baseline of, what are computer languages? I mean, there's got to be, there's 700 plus languages, so there's got to be some kind of organization to them. You know what I mean?
Well, how about we talk about some of the first languages, some of the early languages.
All right,
the Ada language was 1977, but the Algon, the one that you had already talked about, that was 1958. So we have a couple of early languages. Any languages that are early languages that you'd like to talk about?
Well, Fortran is a big language. Fortran was formula translation. So as you start to look at computer languages, they kind of fall into different groups. So Fortran is in the scientific group. So a lot of the early programming was scientific, right? It wasn't business. So Fortran's one of those. APL is one of those. APL is a matrix, a very advanced and slightly cryptic matrix, like think gigantic spreadsheets, that type of thing. So you've got scientific languages, you've got business languages, you've got teaching languages, you've got database languages, you've got scripting languages.
Are there any languages that create languages?
Oh boy, you got me on that one. I'm going to say yes. Even I touched on that long time ago, and I'm not even going to say when, where we had code that would write code.
Right. That's
So,
what I'm thinking. There's
you-
code that writes code?
You can definitely do that. And now we're in this age of AI, and so who knows what they're doing with AI? Definitely the concept or the one of the thoughts is you have computer programs write computer programs, right?
Right.
On their own. We wrote computer programs that we would write programs, but we were directing what we were trying to output. We were just trying to do repetitive stuff. But now we talk about AI. AI is popular now, but AI. Go back and look on the cheat sheet. One of the first AI languages is Lisp, right? Look at the year that Lisp was created
1958 by John McCarthy
at MIT.
at MIT.
Yeah. We did this cheat sheet, and I think what's really interesting is where these things come from. And there were some patterns. They either came from universities, or they came from businesses like IBM and AT&T and Bell Labs, or they came from consortiums, or they came from like individual contributors and stuff. So you can trace most of these languages back to specific authors. Like we talked about before, Dennis Ritchie. When we talk about Python, this guy who created Python is somewhat of a deity, Guido van Rossum, and he worked for some company called CWI in the Netherlands, but he transformed computer programming.
Wow. And what was his transformation?
I think there's a couple things, but Python, the benefit of Python is it kind of they call it batteries included.
What? Batteries included?
Well, it came with everything you kind of needed. It came with all the libraries and all the goodies and all the extra stuff. I'm kind of moving into this thing about Python, why Python is so popular, right? You hear about it, right? Everybody's...
Oh, sure. Python is really...
I want my kid to study Python.
Yeah. Everybody wants them to learn Python.
Okay. Well, here's why. Kind of jumping around, but when we go back and we look at what we were studying here about these compilers, so these early pioneers that wrote these compilers that converted language...
Grace Hopper.
You got her, right? So the way a compiler works is that you have to take the code, run it through the compiler, and it takes a while. So it just takes time because there's a lot of stuff that's happening, and sometimes your programs get big, and you might have to wait, right? So you might have to wait 10 minutes for your program to compile. Now this was early, and this is in the 80s and the 90s, and you have to wait to compile. The problem with waiting is you can't test. It's hard to test, retest, fix, and let's say you screw up and you make a mistake. Well, then you got to change it, and then you got to wait 10 more minutes again. So this is the old way of programming, is this compile.
Okay.
Python, I know, look at the cheat sheet, is popular today, but when was it written?
1991.
So 1991, so that was 30 years ago. Now, the difference with Python and these other languages, and Python's not the only one, but it's an interpreted language. So there's no compiler, or the concept is it compiles on the fly. You don't have to wait 10 minutes. It just goes. And so instead of being quote unquote compiled, it's interpreted. Now, that didn't work in the 90s and it didn't work in the early 2000s. But once we got enough hardware, it now works. And you can prototype very quickly with Python because you can run it immediately. You don't have to wait for the compile. So that makes a huge difference to business.
I can see that. Yeah, speed is everything, right?
Well, it's prototyping. So you can prototype extremely fast with Python.
That's great. Any other languages that you can prototype fast with? Or is Python, once Python came out, that was...
So BASIC was one of these.
BASIC's been around for a long time, though. That was 1964.
Right. And so my cheat sheet says BASIC means Beginner's All-Purpose Symbolic Instruction Code. How exciting.
Wow. And
I have here John G. Kemeny and Thomas E. Kurtz out of Dartmouth. So this comes out of a university.
Right. Dartmouth. Good school.
Oh, absolutely. Look at Scratch. I mean, because we talked about Scratch is another one of these. Scratch is kind of in a category of its own because it's for kids, but that's also a interpreted language. And I thought that was interesting where it came from.
Yeah, it takes its name from a technique used by disc jockeys called scratching.
Well, you gotta. There's page 2.
So scratching is where what you do on the vinyl records. They're clipped together and then they're manipulated on the turntable to produce a different sound effects and music. Like scratching, the website lets users mix together different medias, including graphics, sounds, and other programs, in creative ways by creating and remixing projects like video games and animation.
Yeah, and so that comes out of... You okay there?
Yeah, I'm okay there.
Okay. That comes out of MIT in 2003. It comes out of MIT's what they call the Media Lab. And it's the Media Lab's lifelong kindergarten group. And it's led by Mitchell Resnick.
Did they actually have kindergartners there testing it out?
I don't know. My research only goes so far.
Okay. I'll have to find that out.
But
find out if their test lab consisted of little kindergartners.
Right. You know what? There are more notes. They did partner with another company, so that consulted with them, specializing in young children's education.
Oh, okay. So MIT partnered with another company. Okay.
Yeah, and again, it's MIT's Media Lab, so it's this whole separate entity that they have there that does fun stuff. But let's look at Scratch. So Scratch is totally different than every other language. And again, people kind of dumb it down because it's made for kids. But it's graphical. And it's easy to use. And it's kind of plug and play and drop. You love it, right?
Right, I do. It makes it easy for me. You make less errors. You're not doing what they call the syntax.
Right.
You don't have syntax errors here because it's a block, and you drag a block over, which the code is perfectly written for you in this block shape, and you just piece together the blocks and tell it what you want to do. It's very, very easy to understand. It's very quick to learn. So you're programming very, very quickly. That's why it's great for kids.
Right, and it's simple, right?
Mm-hmm.
I find it a little bit limiting. I mean, I've written with it. I've written some fun stuff, some fun games. And the editor, although it's kind of weird, it's hard to see all your code at one time. And I think if they improved it where you could see more of what you're writing and just make that interface a little bit better, it'd be good. But this could be, and I'm not saying it is, but it could be the future of programming because, programming has evolved from like cards. Everything was written on cards. Then we had text languages and text screens. Now we have graphical user interfaces and these fancy development environments. So, but today, all programming is like written text, but why can't it be graphical and oriented?
Sure. I mean, it makes it so easy, less mistakes, and faster. But I guess one of the reasons why, it's not all graphical now is that, like you said, it takes up too much space on your screen.
Yeah, I mean they got to work on the interface, but this whole concept of
Interface?
Interface just means the tool you use.
The tool you use to...
Well, Scratch. What are you talking about?
Okay, Scratch interface. Okay, gotcha.
Right. So when you play with Scratch and when you write with it, you've got this little box where you drop all your little graphical
The
blocks.
stage, right?
I guess that's what you call it. Right.
Okay.
So that just needs. I mean, my thought is, we now are able to program with pictures. Why can't you do more of that and make it more advanced?
Right.
And see your programs visually.
Well, there's a program out there called Blockly that pretty new to the market too, 2012. That one uses blocks.
Yeah, I think that's Google.
Neil Fraser began the project with Kuhn Neutron.
Okay.
The contributors were at Google.
Right, so Blockly. So I think we're going in that direction. I think computer languages. I mean, I think about when at work when we read this code, you got to read it, and then you're just reading so much code, and you got to keep track of what it's doing. If it were visually represented, I think it'd be so much easier to deal with.
Yeah, I think so too. And you know what? The population that would be able to the entry into that programming coding would be more vast because it's easier. You're going to have more entry level people getting into it.
Yeah, cool. So let's just. I know I'm jumping around, but we didn't really pay justice to a lot of the big languages that are kind of recent, last couple decades. But C. Kind of there's a little bit of an evolution here of C, then there's C++, which is really the object-oriented version of C. Then Java comes on the scene, and JavaScript, Java and JavaScript, which are completely different from each other, come on the scene at the same time. Java comes out of Sun, and JavaScript comes out of Netscape, and basically the difference is Java is this kind of, I don't even know what you call it, golden jewel that really transforms client-server programming and allows the code to run dynamically in almost any environment. And then JavaScript becomes this new user interface that goes onto all the browsers. So those are, those were the biggies. And there's a ton of business code out there. I mean, COBOL ruled the world it's still out there, but it ruled the world in the 70s and 80s, maybe even into the 90s. Then Java, C++ took over. Then Java really took over. So there's a ton of Java code out there. But Java's a little bit of a difficult language. It's very strict. So I again, these are only my views, but I think the big powerhouses today are Java and Python. Those are the big kind of engines. There are tons of other adaptable tools for user interfaces. But the big difference is that Java's very strict and very rigid, and Python's very loose and very forgiving.
Ah. Mm-hmm. And they're all business languages.
Yes, they can be used for many things, but they're essentially used for business.
Primarily used in business.
Well, but not necessarily. I mean, they can still be used for research and education, and it depends on the libraries that are in there too. But I would say, kind of as a wrap up, if I were new to programming, I think the easiest language, and it's very powerful and used in many, many places, is Python. Python is like the basic of the 1970s and 1980s. A lot of people wrote in BASIC because it was easy. Python, from a text language, is probably the easiest one to get started with.
Okay. Well, that's a wrap for today then.
Okay, we're wrapping it up.
We're wrapping it up.
Okay, I like your sign off. You like the last sign off you did last time was great.
What did I do?
You thanked all your listeners.
Oh, that sign off.
I'm sorry.
Thanks everyone for listening to our podcast today. And this is Totally Code, and we'll see you next time.
Bye-bye.
Bye. I didn't like that one.